And welcome back. Now today I'm going to talk to you about how we can get your Arduino to sort out when things go wrong. Basically, what happens if the peripheral external device that you're connected to suddenly decides not to play ball anymore. Or indeed, the Arduino itself isn't going to play ball because, well, shock horror, your code isn't quite as robust as you might have thought. It's in some kind of loop, it's waiting for a response, that response doesn't come and you just sit there forever. Now, without stating the obvious, this has got a reset button on it, and that's fine. You can press that while you're developing. Great. Who puts a reset button on their device when it's built into a project? Me neither. It's not one of those things you really think about. And yet, my PC at work used to have a reset button. Now it doesn't. And I really miss it because it means I've got to actually power down the entire PC rather than just pressing reset, and powering down the PC powers down everything else that's connected to it via the USB. It would be nice to have a reset button. First things first, you could put a reset button on your project for when things go wrong that you press manually. I know it sounds a bit extreme, but it could work. Secondly, of course, you've got power. I mean, to reset this now, all I've got to do is pull the plug, and I'm guessing that even when it's in a live situation, I'll be able to switch something off, probably the wall wart or something, just to sort of kill it. So a power switch on the project somewhere, wherever it's mounted, is an obvious choice, isn't it? But these are sort of teaching grandmothers to suck eggs, really. We're not really getting to the hub of the matter. What if this device was in fact 50 meters down the bottom of your very long garden, in the middle of a beehive, perhaps measuring the temperature, humidity, and the number of bees going in and out? It's not the sort of thing really that you want to fail during one day, when in fact you don't even get down there every day to check that it's still running. How do we make this a little bit more robust so that the things it's connected to, like here we're emulating a peripheral with this LED, how can we make sure that this talks to that and doesn't sort of sit there in an endless loop going wrong? Well, let's have a look at the code window first and have a look at the obvious. Now on your board, on every Arduino board of course, you do have a reset pin. So if I bring another board closer to the camera, you will of course have seen the reset pin, and there it is. Right, now I suspect not many people connect things to that reset pin, because after all you've got a reset button here and that works just fine. So what on earth is there a reset pin here for? Well, you can use it to programmatically reset your Arduino, and this is how you do it. So on this code we've decided to have a reset pin called 7. That's the actual pin that is going to be set to bring the reset pin down low. So the first thing we've got to do, rather than just setting it as a standard output pin, because what's going to happen is it will go low immediately and reset your Arduino, which means your Arduino will just never boot up. So what we do here, we're saying the first thing we're doing is setting this pin high. Then we're setting it as an output pin, and that's all there is to that little bit of it as part of the setup. Here we've got a little bit of debugging just so we can see what's going on. And we're going to flash an LED as well, so we've got pin 13, which is the standard LED one, set to an output. Now in the main loop, we're having first of all a little loop here to flash the LED on and off a few times, just to prove that the circuit is running and emulating your masterpiece of code. Then what we're going to do is reset the board after 3 seconds by bringing this pin low. So on the actual board itself, so on this board we've got the reset pin, which is this blue wire here, connected to, let me see if I can get a bit closer, there we are, so a little bit closer. So that reset pin, the blue wire, is connected here to pin 7. Okay, now I've read on the Arduino forum that, oh no, you mustn't do this, who knows what's going to happen if you do that. But the fact of the matter is that that reset pin is already at a positive potential. The standard schematic for an Uno, for example, has got a pull-up resistor, an external pull-up resistor on this board somewhere that brings it to plus 5 volts. So you setting it to an output pin is going to do no harm whatsoever. So here we are, we're going to bring it low, and the data sheet says you've got to bring it whole for 2 microseconds before it will actually action. And then of course this bit of code here we should never see. So let's have a look. So if we watch this running, I'm going to press the reset button. There we are. Now what we can do is check what happens on the output window when this loads up. Let's close it and reopen it, that'll be the best. Oh, here it's already going, it's already going. So it's flashing the LED, going into reset, is it? And there it is. And it says check the LED state. Well, the LED is off. So that truly is a reset, because as you know, when the Arduino starts up, all the GPIO pins are low. So that's fine. It's bringing what was a high LED, as we can see here, it's flashy, flashy. Just watch it through once more time. It's high, it's going to reset, there it goes, and it's low. Now there's absolutely nothing wrong with that as far as I can see. So that is an obvious way to do it, by connecting any GPIO pin to your reset. Remembering though, you must set it high first. There we are. So just remember that you've got to set the digital pin high before you set it as an output mode, because otherwise the minute you set it as an output it will go low and that will reset your Arduino instantly. You don't want that. So that's one way of doing it. So if your Arduino program decides things aren't working right, I'm going to reset everything, or I'm going to reset myself, effectively is what we're saying, that's the way to do it. Fine. What other ways can we do? Well, this is something I found on the Arduino forum. I wasn't aware of this, but I'm going to load this up and we'll see why this isn't such a great idea, in fact. Now this code declares a pointer to a function, this reset function I've called it, to a memory address of 0. So all it's saying is there's a reset function starting at memory address 0, and we're going to call it instead of doing that reset we did. There it is, there's the call. The code is otherwise identical. Does it work? Well, let's bring in the board again. Now, what we're looking at here, it's flashing, so it's in that main loop. Reset, it's saying, am I going to reset? It's set up, but look, the LED's still lit. Look at this. That is not a proper reset. That means, yes, the code went back into the reset portion of the Arduino code, but it hasn't reset the GPIOs at all, because this LED stays high after a reset. So that's not maybe what you want necessarily. So that's not a good idea. Having this pseudo made up function pointing at memory address 0, that is not a good way to go. So what else can we do then? That was how you declared it, by the way. I'll put all these program demos down at the bottom of this code, of this video, so you can have a look and experiment. But that one I don't think is on the cards, to be honest. So what else have we got? Let's have a look at this one. Now this is I think the best way of resetting your Arduino. This is using the Watchdog timer. Now the Watchdog timer basically says, unless you tell me everything is okay periodically, I'm going to reset the Arduino board. Now this means, of course, that your Arduino board has to tell it periodically, and before the time elapsed has expired, that things are going well, otherwise your Arduino will suddenly reset in the middle, which in fact we're going to use to our advantage in this demo just to emulate. So we have to bring in this library to enable the Watchdog to run. The very first thing we do is disable the Watchdog, just in case we left it running for something else. Everything else is pretty much the same in the setup. Now here is where we define the Watchdog timer. Now there are various options for this, from milliseconds down to 8 seconds, and they all look a bit like this. WD, so it's Watchdog timeout underscore, this one 2S, so that's 2 seconds. So what it means is, once you've enabled the timer, you must periodically tell it, everything's fine, don't reset my Arduino, thank you. So in the loop, here we have our loop for flashy, flashy LED. At the end of every flash, we're going to say, everything's fine. And if you look at the delays here, we've got half a second on each. So that's 1 second. So every second we're basically saying everything's fine, do not reset my Arduino. We're resetting the Watchdog timer. Now then what we're going to do, after 5 lots of flashes, we're going to say, can we reset it? And we're going to put a delay in of 3000 milliseconds, or 3 seconds, which is of course longer than what we've told it the timeout is going to be. So the effect of that is going to be, after 2 seconds, the Watchdog timer is going to say, something's gone wrong, I'm going to reset. So let's load this up and just see what happens. Right, so here we are. Now this is using the Watchdog timer. So let's bring in the code and that. So what we're looking for is this LED to be in the low state. Now it's saying setup at the moment. Check the LED. Yeah, it's flashy, flashy. And in the setup, the LED is off, which is what you expect. Then it's going through the main loop, flashing a few times, saying, can we reset by the Watchdog? It's just delaying. Whoa, there we are, we're back in the reset, in the setup. So that means the Watchdog timer is leaping in to do its business. It says, well, 2 seconds have elapsed, you haven't told me that everything's okay, so I'm just going to reset your board. Simple as that. Now that does mean, in your code, you've got to really pay attention to what you're doing, and if you do have delays and the like, you're going to have to watch that those delays don't exceed the Watchdog timeout. So your code will effectively be liberally sprinkled with these WDT resets. Now it might be that you can get away with just doing it at the start of the loop, depending on how quickly the loop runs for. But you really will have to pay attention, and if suddenly your reset does happen in the middle of what you consider to be a perfectly normal program function, then you'll know the reason. Right, let's go on to the final example now of how to reset your Arduino. Now, this is a bit of a cheat really, this last one. This is with a relay. Now let's go back to the workbench and have a closer look at this. Right. Now what we've got here is a standard Arduino connected to a flashing LED, as we've had through all these little tests, but this time the power for the Arduino is going to be supplied through this little circuit board. Now you can get these from eBay in the Far East. I can just zoom in on that a little bit so you can get a clearer picture. So you see that this thing fits directly onto this breadboard, it's designed for it, and you get a choice of 5.5 or 3.3 volts by flicking this little switch in here. So currently that's set up for 5 volts, and as you can see at the moment, it's actually the power's coming from the Arduino back into this board, which is fine for our demos, but we actually want to plug power in here and have it flow that way, and not have it powered by the actual USB socket like we have at the moment here. So what we're going to do is load up the program. Now what happens on this instance is that the power's coming in here. It's going via this relay. Now this relay board you might recognise from a previous demo I did. We're only using half, so ignore this half. We're using a single relay, which is this one here, via the opto transistor. So this relay, and we're using the normally closed relay points to say, right, the power flows into this relay, back out again, into the Arduino, and that's how it is. Now everything that comes out of here, this red LED here, is also indicating perhaps a peripheral or something. So this is also being controlled by this relay, which in turn, this whole relay is controlled by your Arduino. Okay, there's a little transistor here and whatnot. I'll draw the circuit out in a minute, and I'll upload that as well. But basically your Arduino is controlling whether this relay stays in its default status of normally closed contacts, or whether the Arduino can say, do you know what, I've had enough, nothing's responding, my Wi-Fi module isn't sending me anything anymore, I'm going to reset the power on the entire project, everything, not just the Arduino, but everything connected to the power out of this relay. and being a relay, of course, it can handle quite a bit of power. So let's upload that. Then we have to disconnect this power in here, and we'll see what happens. Right, let's quick transition to the window there. We're going to upload this. There it goes. Right, now you probably heard that noise. If I fade across to that. Now this is going a bit mad here, look. This is trying to do things to this relay it was never designed to do with this power here, so I'm going to unplug it. Anything from 9 to 12 will work here, so let's plug that in. Right, now you can see here, this red LED is on, that's emulating some sort of external peripheral, your sensor. Just ignore the clicking for now and everything, we'll come into that. There's the little flashy demo code, just to prove that the Arduino is actually running something. And on here I've got a digital voltmeter to show when the power is supplied. So what's going on here then? Well, let's go back to the code window. Right, in the code window, what's going on here is everything here is pretty much normal. With the we're just setting up the serial pin 13, the flashy LED, but also here we're setting up pin mode 8. That's so it's GPIO 8 as an output. So if I bring that across there, we'll be able to see a bit better. So on here we got GPIO 8 as being an output, and that output goes from the board by this blue line into a little transistor which I've got down here. The output from the pin 8 is going into the base of the transistor. The transistor is going through this LED or opto isolator on the relay, and that in turn controls the whole thing. So it's happening all the time, but let's go through the code and we'll see. So we're going through this loop and flashing the LEDs first of all. That's fine. And you can see the LEDs flashing there 5 times. At the end of 5 times though, what's happening in this code, it's saying, right, I'm going to reset all the power by bringing the digital pin high, and we can see what's happening if we look really closely now at the workbench by itself. So flashy, then what you notice after the flashy and in time with that click is that this LED here goes off. The power on the Arduino goes off because everything is cut off. The only LED remaining is this one right at the end here, which is in fact the power into this little board. But that's all that's powering. Everything else is coming from this relay, normally closed contacts. So the Arduino is saying, do you know what, I've had enough. I'm pulsing this output here, which in turn is driving the opto isolator on this relay. It's opening the contacts, which is effectively switching off all the power to the entire circuit, and it obviously then resets. It's exactly the same as pulling the plug out of the USB socket. And you can do that programmatically, of course. So if the Watchdog timer isn't enough for you, because all that does is reset the Arduino, yes, it does bring the GPIO pins back to the standard state and everything, but your peripherals might have died. What if your Wi-Fi module or your humidity sensor or whatever has just got itself hung up? Well, by doing this, it means this relay, which controls all the power to the entire project, can basically, it's like you pulling this plug for about half a second and pushing it back in again. Everything starts from scratch. Could be a lifesaver with this thing buried in the middle of a beehive down the bottom of your garden in the rain, November, 8 PM, raining. You get the idea. Where things are inaccessible and you can't switch off by yourself, it's always a good idea to have something else do it for you. Now, of course, your code has got to be a lot more sophisticated than this. So the demo code that I'm putting here is all very well for a demo, but of course what you'd have to do is probably log the fact that you've reset the Arduino. You might want to put it to an SD card. I think my last video was about SD cards, wasn't it? The one before, can't remember. So you'd log the fact you're going to reset and I guess that by that time you hope that the SD card is going to respond, because if not, well, you'll never know, but this will have reset. So there we are then, several ways to reset your code, from the obvious on-off and reset button on the board itself, to Watchdog timers, some strange weird pointer to a method that doesn't really exist and doesn't, yes, it resets the Arduino but not properly, it doesn't set the GPIO pins down. Watchdog timer, probably the best way to reset just the Arduino, and then of course this method that powers off everything. This little circuit here, by the way, it's only a little transistor, a capacitor and a resistor, which I'll add into the stuff down below of this video, and I can draw this for you now. So let's just make a bit of room. Right, so stop this clicking and driving me mad. We're going to power that down. Now, if you've watched my previous video on the relay, you'll understand that the relay itself is an opto-isolator, so it wants some power in. Internally it then goes through an LED as an opto-coupler in here. It's even got a resistor, and then it says, strangely enough, on the board here, on this actual module, it actually says in, but it's not. It's the current wants to go out, so really that needs to go to earth. So what we're going to do is, on our Arduino we have an output on GPIO. What do I put it on? 8 in this case, but it can be any GPIO, and we want to drive the current through here. So we connect this to plus 5 volts, that's fine, but this bit here we don't want to switch on until this happens. So that goes into a transistor like this. This would normally go into here, but we're going to just make a couple of little changes. That's common ground, that goes to common ground as well. So here we have a small little resistor of about 10k, and also here you need a capacitor. Now at the moment I've got 47 microfarads. That is enough to make it a decent pulse of about, I think you heard there, about 1 second pulse probably. You don't want it too short. When I first played around with this, I had about a 1 microfarad here. That was too short. I only did it for like 1/10 of a second. I think lots of peripherals might get upset at that power being taken away and then reapplied again within that shorter period. This 1 second though I think is great. If you want to extend it, of course you can have 100. You can have 100 microfarads. The capacitors are getting bigger of course by the time you get here, but only 5 volt, perhaps a bit more. Make that 10 volt. Never go too close to the margin. You could even have it up to 250 I suppose if you can find one small enough. Once again 10 volt. I mean, that actually be quite a long pulse, to be quite honest. But basically the stored power that comes out of the Arduino down into this capacitor, stores up this capacitor really quick, feeds back into this transistor. The Arduino by that point has died because this relay that this is operating has opened, but the capacitor keeps this transistor on and therefore keeps the relay open for as long as there's charge on here. So as I say, 47 microfarads is fine, but you can experiment a little bit with that and it can kill your entire project. So remember the output of this relay module, and I always recommend using a relay module like this because all the complexity, if you like, of the boring bits are done for you. I mean, that controls effectively a crossover switch like that. If that's open, this one's shut. So that's normally closed, that's normally open. That's your common. So your power comes in here. The normally closed, that's what feeds 5 volts to everything, including your Arduino. And as soon as you energize this coil, that's going to flip over to here. We're not actually using this thing here, but it breaks this connection here. So everything that was powered dies. So that's a fairly simple way of doing it. Hopefully that's going to give you food for thought and something maybe you can incorporate into your next project. Great, thanks for watching and see you in the next video. I hope you're finding these videos useful and interesting. Remember, you can leave comments down below and also click that little button that says subscribe. Okay, thanks for watching and see you in the next video.